Testudo is a genus of tortoises found in North Africa, Western Asia, and Europe. Several species are under threat in the wild, mainly from habitat destruction. They are small tortoises, ranging in length from 7.0 to 35 centimeters and in weight from 0.7 to 7.0 kilogram. Systematics. The systematics and taxonomy of Testudo is notoriously problematic. Highfield and Martin commented, "Synonymies on Testudo are notoriously difficult to compile with any degree of accuracy. The status of species referred have undergone a great many changes, each change introducing an additional level of complexity and making bibliographic research on the taxa extremely difficult. Most early and not a few later checklists contain a very high proportion of entirely spurious entries, and a considerable number of described species are now considered invalid, either because they are homonyms, non-binomial, or for some other reason. Since then, DNA sequence data have increasingly been used in systematics, but in test students, its usefulness is limited. In some of these, at least mtDNA is known to evolve more slowly in these than in most other animals. Paleobiogeographical considerations suggest the rate of evolution of the mitochondrial 12S RNA gene is 1.0 to 1.6% per million years for the last dozen million years or so in the present genus, and mtDNA evolution rate has been shown to vary strongly even between different population of T. homini. This restricts sequence choice for molecular systematics and makes the use of molecular clocks questionable. Conventionally, 5 species are placed here: Russian tortoise, Horsfield's tortoise, T. horsfieldi; Hermann's tortoise, T. hermanni; Spurth-eyed tortoise, a Greek tortoise, T. Greca; Maghreb tortoise, T. Greca; Greek tortoise, Testudo; Ibera; Persian tortoise, T. zarudni; Kleiman's tortoise or Egyptian tortoise, T. kleimani; Negev tortoise, Werner's tortoise, T. werneri; marginated tortoise, T. marginata. The first two are more distinct and ancient lineages than the closely related latter 3 species. Arguably, T. horsfieldi belongs in a new genus on the basis of the shape of its carapace and plastron, and its distinctness is supported by DNA sequence analysis. Likewise, a separate genus Europe.Testudo has recently been proposed for T. homini. These 3 lineages were distinct by the late Miocene as evidenced by the fossil record. Whether these splits will eventually be accepted remains to be seen. The genus Chersis has been proposed to unite the Egyptian and marginated tortoises, which have certain DNA sequence similarities, but the ranges are separated by the closest relative T. Greca and the open C, and thus chance convergent haplotypes. Orting would better explain the biogeographical discrepancy. Conversely, the Greek tortoise is widespread and highly diverse. In this and other species, a high number of subspecies has been described, but not all generally accepted, and several are now considered to be local morphs. Some, such as the Tunisian Spurth-eyed tortoise, have even been separated as a separate genus Feculaceus, but this is not supported by more recent studies. However, the Greek tortoise likely will be split into 2 or more species in the near future.